Hey guys, welcome to this week's NAEP item that I chose here, and tying a Geogebra app or discussion to a static NAEP item like this. We can kind of get some depth and see some lecture opportunities and some understanding for ourselves and for our students. So this question is just saying, what's the solution to this absolute value inequality? An easy way to do this, if you just want to show the students the solution, is to open up Geogebra, turn on your axes in your grid, and maybe I'm just going to center my grid here. So if you don't want to grab your Move Graphics tool, this is really the tool that'll move the coordinate grid all over. You can see your little hand when you hold the left mouse button down. Your little hand turns to a fist like it's grabbing the screen, and you can drag it around. But a shortcut key, no matter what tool you have in Geogebra, if you want to move the screen around, just hold Control down on your keyboard and then hold the left mouse button down and drag, and it does the same thing. Okay, so we got our grid up here. Let's go ahead and just put in, say, the absolute value, and we had the absolute value of 2x minus 5. So I'm just going to type that in here. In Geogebra, you have to use ABS and then parentheses for absolute value, and then we have 2x minus 5. So when we hit enter, it gives us that graph. Okay, and then we can just put in the constant value. So this number pattern, we want to see, what values have, what x values give us outputs that are greater than 3. So I'm going to just put a horizontal line where y equals 3 on the grid as well. Y equals 3. And there's our really our inequality here. This is what we're looking at. If we had the equation, we would ask ourselves, where do these two number patterns, these two functions basically, where do they intersect at? And it would be at 1, 3 and 4, 3. So we could solve that. But the question really is, less than 3. So if you can tell by outputs, if you can get your students to understand that really we want the outputs that are, I'm sorry, I got that backwards. This is greater than or equal to 3. So outputs that are greater than 3, which would be, these x values that are less than 1, that give us, these points. And we can actually, let's put a point on the curve here. So what we can do too is, if we right click a point, we can go to Object Properties. In the Properties option, we have the Show Label here, and right now it's just showing the name, but I'm going to click this arrow and I'm going to have it show its value. So as we slide this point around, you can see x and y values of that point. I don't know if you can hear that. My son is a little 1-year-old who's around me. Anyways, as I slide this point, you can see the y values are greater than 3, and they happen with x values that are less than 1. So as we get down in this region, they can see that the y values are less than 3 here. Okay, but then to get the values greater than 3 again, we have y values that are greater than 4. And so we can see our solutions here are going to be x's that are less than or equal to 1 and greater than or equal to 4. So that would be our answer, and then we can go here and do that. Here's our answer. 1's less than 1, or x is less than 1 and greater than 4. Okay? Now to kind of spice it up here, I made an app here that you can open. I'm going to actually have to open mine. Sorry, I thought I had this prepared. So this is the app that I put in this topic for this week. It's a absolute value equation and inequality app, and it's got a whole lot of stuff going on here. Let me kind of explain the app here in this video, and then the next video that's in this week's topic too will explain how I made this thing. So what I have here is this dotted line here is going to be our reference tool. When I teach transformations of functions, I like to keep the parent function here. So this is just our parent absolute value curve. We have, I have our general absolute value equation here, or form here, and I have it something to see, and there's this less than or equal to, less than, greater than equal to, greater than, and equal check boxes here. So let's say that we wanted to do, let's see if we can represent that equation that we had here. Now this is in our parent function form. In our actual equation we had that 2x minus 5, so with x there is a number multiplying x in here, and it doesn't look represented in this parent function here, but we can probably figure out what a and h have to be so that we can get the absolute value of 2x minus 5. But what we can do is we can change our sliders around. So if I make a 1, for example, and we also have, actually I'll do greater than here. What I did was when you click on an inequality, your solutions are actually down here on the x-axis, because that's what our number line really represents in those problems. I like to use horizontal number lines in context to the graph so that we get some kind of value of why we even care about one number lines like that, like the solutions right here. Okay, this is really our x-axis here, right? And we got our y-axis just overlaid on top. So I have these lines here where we can change our constant that we want our absolute value expression to be compared to, so we can do greater than, less than, anything like that. And notice that everything, when we slide, everything stays nice in our relationship. We can change our, how we translate the function around. So we can get back to that parent function. And here's our expression. So what I like to do when I make an app, if I have sliders that change values around, like the a coefficient, the h, the k here, I like to color coordinate them, and then in my equation keep that color so that they know that when I move a, it's really affecting this, and when I move h, it's really affecting the green h here, move k, affecting the blue k, and then the constant would be this green one down here. And we can do, again, greater than, uncheck that. We can do less than if we wanted to. Notice if it's less than or if it's greater than, we have the open circles. If it's equal to, we have the closed circles. Okay, and then we can see the expression changing dynamically as we change our expressions around, and it allows us to take these and introduce the algebra concept to what we see up here. I put the coordinates of all these points that I have right here just to kind of help with the input-output concept. If you just put in, say, a 1 here, we would expect to get out a half based off of this, and you can check too. 1 minus a half is a half. Absolute value of that is still a half, and you have one of those, so there's our half. So you can make a ton of connections depending on where you're at in your lecture, what you want your students to see. You can hide some extra things if you want to, and I can show you how to hide stuff if you're curious. But what this function, or this app, does, again, it allows you to create any kind of function you want, absolute value wise, and we can see the solutions too. And even when we don't have the intersection, we don't get solutions. So when students try to solve algebraic try to solve these absolute value inequalities algebraically, we can see the no solution here, and we can understand that when we subtract 4 over here and we get 1.5 left, and then we divide by a -2, now our absolute value is compared to a negative number, and it'll never they'll never equal, there'll never be an intersection. Okay, so play around with this app here. It's pretty neat. And actually, let's go back to, let's solve that. Let's represent the absolute value. I'm just going to use my pen tool. Absolute value of 2x minus 5 is greater than or equal to 3 was our problem from the NAEP item here. So if we think about the parent function here, then we need to have 2 as our a times the absolute value of x minus 2.5, right? That's going to be the same thing, is greater than or equal to 3. So now I know that if you give these to your students, if they want to just represent it, let's let a be 2. And you can also use your directional pad on your keyboard. Every time you hit it, your slider will just move up by your jump. So I want my a to be 2. I want my h to be 2.5. Okay, and then I want my k, there is no k, so I'm going to set it to 0. And there's our solution, and we want it to be greater than or equal to 3. So I'm going to move my constant to 3, and we can see our solutions right here. All the x is less than 1, all the x is greater than 4. Okay, so play around with this app and see what you think about it. Thanks, guys.